Okay, last one for today, number 3. A rocket is launched from a platform that is 48 feet high. So that's telling us we're already on a platform of 48 feet. We're not starting on the ground. The rocket's height above the ground is modeled by, and they give us our function. H equals negative 16t squared plus 32t plus 48. The plus 48 is where we get the fact that we're already starting 48 feet above the ground. So we want to find the maximum height of the rocket. We're going to look at negative b over 2a. B here is 32, so we have negative 32 over 2 times a. Well, that's going to be negative 32 divided by negative 32. And we all know anything divided by itself is 1. So that means 1 second after we launch our rocket, it is at its highest point. So that means our t is 1. So we want to plug that in and find h. So negative 16, t is 1. 32, again, t is 1. We add 48. Well, that's going to be negative 16 plus 32 plus 48, which is 64. And we know it's feet. We know it's feet this time because they did tell us in the problem. So by using negative b over 2a, we put in the 32 and the 16, negative 16 in the appropriate spots and simplify. We get that t equals 1, so 1 second after we launch it, it's at its highest point. We plug that highest point time, which is 1, into our function, and we solve to get our h. So we ended up 64 feet. We want to know when is it going to hit the ground. So when we're on the ground, we are 0 feet above the ground. So we're going to take that function and we're going to set it equal to 0. And then we're going to try to factor it if we can. Well, negative 16, 32, and 48, those are kind of big numbers. However, they're all divisible by negative 16. So we can factor it out front like we did in number 2. Then I get t squared minus 2t minus 3. Then if I divide both sides by negative 16, I get t squared minus 2t minus 3 equals 0. Because 0 divided by negative 16 is still 0. This is actually nicer than problem number 2 because since our a is now 1, this is just a regular diamond problem. Negative 3 goes in the top, negative 2 goes in the bottom. So what two numbers multiply to be negative 3 but add to be negative 2? Don't forget you can use 1. So it's negative 3 and 1. That means my factors are t minus 3 and t plus 1. We now have two things multiplying to be 0, so we can use the zero product property. That means t minus 3 could be 0, t plus 1 could be 0. So that means t is 3 or t is negative 1. But again, only one of these is correct, and I'm hopeful that you're all paying enough attention to know that it's the positive value. So it is 3 seconds after we shoot the rocket that it will reach the ground. Negative 1, while it is a 0 of the function, it does not make sense in the context of the story because we're not going backward in time to shoot the rocket or for it to start on the ground. So please, 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 I can't say enough pleases, think about what's happening in the story problem. Don't just start solving, don't just get in a hurry. And again, several of you are doing this or you did this before. Do not pull the numbers straight out of the diamond problem because it's not negative 3 and positive 1 as our solutions. Our solutions are positive 3 and negative 1. So you will not lose an arm from writing by writing out your factors, separating them using the zero product property, and then solving each of those separately. You might have to watch these multiple times, and I know I'm boring, and I'm sorry, but this is a lot of stuff, and I know it's hard to do at home by yourself. So please make sure you're emailing me questions. Drop in those Google Meets and ask me a question. Whatever I can do to try to help you out. I know it's a lot, but please keep at it.